Hello, I'm Wanpeng Li from Tencent Cloud. I'm a long-term active KVM contributor in community. Today, I will introduce some KVM latency and scalability optimizations. This is today's agenda. Firstly, I will introduce Fastpath for both IPI delivery and the TSC-Deadline timer. Then I will introduce how to boost vCPUs that are delivering interrupts. ICR and the TSC-Deadline MSR write cause the main MSRs write vmexits in cloud environment observation. Multicast IPIs are not as common as unicast IPI, like reschedule vector and call function single vector. We introduce Fastpath handler to handle certain performance critical MSRs in a very early stage of KVM vmexit handler. After writing ICR vmexit, various get states save and host states load, various condition checking, host interrupts and preemption enabled, and also expensive RCU operations. We even can be interrupt or preempted after host interrupts and preempted enabled. This mechanism is specifically used for accelerating writes to X2 ICR that attempt to send a virtual IPI with physical destination mode, fixed delivery mode, and single target. The reason this mechanism significantly reduces the latency of such virtual IPI is by sending the virtual IPI to the target vCPU in a very early stage of KVM exit handler, before host interrupts are enabled and before expensive operations such as requiring KVM SRCU lock. We can observe 30% latency reduce for IPI benchmark and 22.3% latency reduce for KVM unit test. AMD SVM introduced hardware acceleration to boost virtual IPI performance. The source IPI doesn't need to vmexit when sending unicast IPI or multicast IPIs in most conditions. The virtual IPI can be sent to target virtual CPU directly. We ran Hackbench and IPI benchmark on one AMD ROM server, 2 sockets, 96 cores, 192 threads. The VM is 180 vCPUs with SAP exposed. We can observe 3% Hackbench performance improve. It benefits single target IPI. However, we observe 55.2% IPI benchmark performance drop for multicast IPIs. It is weird that hardware acceleration worse than software emulation. Now I will introduce virtual TSC-Deadline timer Fastpath. Both ARM timer and timer fair incur vmexits. KVM does various housekeeping tasks before emulation. We implement a Fastpath for emulation of writes to the TSC-Deadline MSR. Besides shortcutting various housekeeping tasks in the vCPU loop, the Fastpath can also deliver the timer interrupt directly without going through KVM request pending timer because it runs in vCPU context. We also implement a Fastpath for the preemption timer vmexit. The vmexit can be handled quickly, so it can be performed with interrupts off and going back directly to the host. We can observe cyclic test latency reduced by 16.5%. Next, I will introduce the mechanism to boost preempted vCPUs. To mitigate lock holder preemption issue, vCPU which spin is detected by hardware, while in-house vCPU yields time to lock holder candidate vCPU which is selected by heuristic algorithm. Now we want to boost not just lock holders but also vCPUs that are delivering interrupts. Most SMP call function many calls are synchronous, so the IPI target vCPUs are also good yield candidates. We boost vCPUs during wake up and interrupt delivery time. Next is boost Q-head vCPU. Due to the FIFO order spin lock algorithm, whenever a hypervisor preempts the next waiter that has not yet acquired the lock, even if the lock is released, no other thread is allowed to acquire it until the next waiter is allowed to run. Overcommitment increases the likelihood that the Q-head vCPU may have been preempted and not actively spinning. Reschedule Q-head vCPU timely to acquire the lock can get better performance than just depending on lock stealing in oversubscribed scenario. The lock holder vCPU yields to the Q-head vCPU when unlocked. To boost Q-head vCPU which is involuntary preemption or the one which is voluntary halt due to fail to acquire the lock after a short spin in the guest. The last one is a new hypercall to yield to IPI target. When sending a call function IPI many to vCPU, yield if any of the IPI target vCPU was preempted. We just select the preempted target vCPU which we found since the stage of target vCPU can change underneath and to avoid risk conditions. Let's see the performance number. We test this on a Lion Cascade Lake, 2 sockets, 48 cores, 96 threads. Each VM is 96 vCPU. One VM is running eBasic benchmark, other VM running CPU-bound workloads. We can observe 3.4% improvement for one VM, 24% improvement for 2 VMs, 48.3% improvement for 3 VMs. SMP call function many calls can be in call function interrupts and TLB shutdown paths. We disable paravirtual TLB shutdown feature in this testing. Since call function interrupt is not easy to be triggered by user space workload,